Hello everyone. In this we will see the next problem, which is subarray sum equals to k. So given an array of integers nums and the integer k, return the total number of subarrays whose sum equal to k. A subarray is a continuous non-empty sequence of elements within an array. So we have to return here the subarray whose sum is equal to k, given k. So that subarray should be like continuous non-empty sequence of elements. For example, here in this example, we have all ones. 1 plus 1 is 2, and again 1 plus this 1 plus 1 is 2. We should not include consider 1 plus this first one plus last one, because that will not become subarray because they are not continuous. So in the second example you can see k is 3, so 1 plus 2 is 3 and 3 alone 3, so that is the reason output is 2. So let's for this solution we have here I have like three solutions. So the first I'll not going to discuss first two solutions. Those are like brute force methods. So they are taking they will take order of n square time, and they are only passing few test cases, like only 71 test cases are passing, and from 72 test case we are getting it's failing. So you can go through these methods by yourself, like if you wanted to analyze. I will share I'll in share the link of this I have shared this solution in the description. I'll share the link of this in description of this video. And now I'll going to discuss only the method 3, which is very efficient method, which will take only consume order of n time, and the space complexity is order of n. The above two methods will consume a time order of n square and space order of n. So without further, we can go through the solution. So here given here we have given this is here we will take a different example. So initially we have 1 5 2 minus 3 minus 5 11 4 3. So for this our solution is this k is 5 and our solution will be 3, because we get subarrays 5 1 5 2 3 2 minus 3 and 2 minus 3 minus 5 11. So this addition of this subarray is 5, and this subarray is also 5. So that is the reason our answer is 3. So we will see the our method 3. This is not method 1, method 3. So here we have the given array. So initially we calculate the length of the array, then we create a one extra array for storing pre sums. So initially we create this pre array and pre array with default values 0, and we in this array we will be storing the sum till that index. For example, here 1 till that sum is 1, and till here the sum is 6, because 1 plus 5 is 6, and till here sum is 8. So we have 8 here. So similarly we have we are storing here some of the previous numbers till that index. For example, here till here our sum is 5, so that is the reason here 5. And using this initial for loop we are creating that pre array, and then later here what we are doing, we are creating a one dictionary for storing some values. So I'll going to discuss those things while explaining this for loop. And before that, so here we are creating we have created this array. So here if you see we have some 1 and 6 here. So that means from this point to this point it has increased 5 values. So that means our sum our k value is 5, So if we from this point to this point, we have we it got increased to 5, but here we have sum is 6. So if we subtract uh, if we subtract 5 from 6, then we get 1. So if that means if we disincluded this one, then that is our answer. So this 5 alone will stand as our answer. So that's how this condition will work. So like initially this pre of I, which is 6, minus pre of j, which is 1, equal to k, we get k. So if this is satisfying, then it will be our solution. So in that case, what we are doing here is we are converting this equation to this equation. And then what we are doing here is initially like we are iterating through this pre-array, and we are checking in each iteration, we are checking whether this is evaluate that index is present in is k or not. If k, then we are incrementing the counter. Initially we have defined the counter as 0, and we are incrementing the counter if it is k. Here in this case this is not equal to y, so it will not go inside this if condition. Here then it is checking pre I minus k, which is 1 minus 5. Our k value is 5 minus 4. So we are checking if at this point if we have minus 4 like left side, if we have minus 4, then we can get a sum of 5, but we don't have any minus 4 value. So that is the reason we'll not be going inside this if condition, but we will be like in each iteration we'll be tracking the previous values as well. Here 1 has repeated one time. Similarly similarly in next iteration we come to 6, and here 6 we check 6 is equal to k, no. So we go to this if condition and we do 6 minus 5, which means if we have a 1 previously, then if we disinclude that one, then this will become our answer. So that is what previously we are tracking, uh, we have been tracking like one the previous value. So currently we have one time. So here this condition becomes true because 1 is already present one time. So we'll go inside this if condition and we'll increment counter by 1. So we'll get counter by 1. And then in next iteration 8, again 8 minus 5 equal to 3. Whether we have 2 3, no, we don't have 3. So we will in previous also we will include this 6 and one time, and again here now 8 or 8 one time. And then we do since we don't have 3 in our map in our MP dictionary, so we'll be going back, we'll going to next element, which is 5. And 5 minus 5 equal to 0. 0 also not present. Currently we don't have only 1 1 6 1 8 1. So but here this condition becomes true. Before this condition 5 is pre of I, which is 5 is equal to k. So that is the reason we go and increment counter by 1, which becomes 2. And again here 5 minus k, which is 5, 0 0 is not present. So again we include 5 is one time. And again in next iteration 0 is present or not. 0 is not present. 0 is not equal to k, and 0 minus 5 is minus 5. Minus 5 is not present. So again we just include 0 one time. And again go to 11. 11 minus 5 is 6. 6 is like before doing this subtraction, 11 is equal to k, no. And 11 minus 5 is 6. 6 is present in our dictionary, no. Yes, we have 6. So that means from this point to if we exclude 6 from this point, then it will become our answer. For example here if we exclude 6, which is 1 plus 5, then it will become our answer. 2 3 minus 3 and 11. If we add this 2 to 11, it will be, we get 5. So now we will increment again our counter by 1, which is 3, and we include that 11 as well, 11 one time, and we'll go to next iteration, which is 15. 15 minus 5, I haven't included 15, but 15 minus 5 is 10. 10 is not present, 15 is not initially 15 is not equal to k, and also 15 minus 5 is 10. 10 is not equal, so we include 10 as 1, 10 one time, and then next 18. 18 is not equal to k, so we will not go inside this if condition. And 18 minus k, which is 5. 18 minus k is 13. 13 is present or not? No, not present, so we will just include that 18 as well. And we completed iterating through the pre array. So now in our counter we have 3, so we'll be just returning this 3. So here as you can see, here just we have traveled through the array only once, so that is the reason once here and once here, so which is 2n, but we consider the max, which is order of n. Time complexity is order of n, and here we are considering we are taking this extra array for storing the previous sum, uh, which, which is of size n, so that is the reason space complexity is n. And this is how the program will work. The main logic here is preview minus k equal to preview of j. So this is the main logic. We should understand on this. If we understand this logic, then this solution is easy. Even for example, if I take one more example, here 11, 11 here we had 11, 11 minus 5, 6, so we have to exclude 6, so that is the reason we have excluded here. We have checked if 6 is present or not. 6 is present one time, so we so that means we'll be excluding this 1 6, and if our answer will be like, if we add this in original array, we get 5. So that's how this program will work, and this is very efficient method. You can go through the other two solutions as well to get an idea how initially we get an ideas. So yeah, that's it for this video, and I'll share the solutions link, the solutions, 3 solutions links, and this image link in the description of this video. And thank you for watching.